Alrighty, welcome back. I'm going to recap. So we talked about the atom and how we have protons in the nucleus. And those protons have a positive charge. That's why we have a plus sign, right? And then a buffer for them is going to be the neutrons, which have no charge. And I'm going to put a 0. Call it the airline 0. In between them. Then outside the nucleus, we have these roadways for the electrons. We call it roadways because the electrons are constantly moving. So there we have our roadways, and we like to think of our main roadway in Denton. That main roadway that loops around Denton from the lower 35 to the upper 35 is called loop 288, which means that 2 electrons fit in the first shell. Remember, the positive charge is going to attract those electrons because they are negatively charged. So I'm going to write E negative for that. Okay, and they typically are not next to each other because like these, if they were next to each other and they're the same charge, they would repel each other, right? So we want to separate it. Okay, and then the second shell or energy level or cloud would fit 8, 4, 5, 6, 7, 8. Okay, and then the third shell that we study is going to also contain 8. Okay. So, with that said, are we always going to have all 3 shells for every single atom? Absolutely not. Okay. So, with that said, we're going to look at how many of each we will have. So, we looked at the periodic table of elements in one of the videos. So, we're going to look at the periodic table of elements again. And the most important thing that we're going to look at for our protons and our electrons is going to be the atomic number. So, the atomic number is inside the periodic table tile. So a tile is like a square, kind of like the tiles on the floor, right? So inside the periodic table tile at the top is going to be your atomic number. Okay, so like boron has an atomic number of 5. Carbon has an atomic number of 6. Nitrogen has an atomic number of 7. Let's skip over here. So beryllium has an atomic number of 4. Lithium has an atomic number of 3. Okay, so each atomic number tells us something about that element, or the atom of the element, actually. So, well, what does it mean? When we study 8th grade atoms, our protons are positively charged. Well, for each proton we have, we're going to also have a negatively charged electron. So because of that, in a perfect world, our protons and our electrons are going to be equal to each other. Okay, so if we have 2 protons, we'll have 2 electrons, because that's what the equal sign means. They are equal. It's the same number. Okay, so what does it have to do with the atomic number? It's a good question. So when we look at an atomic number, that means our atomic number is going to tell us how many protons and electrons there are. Because that's what it tells us. So when we look at this, our atomic number actually equals our protons, and that equals our electrons. So if we have an atomic number of 5, well, how many protons do we have? It's an equal sign. So the equal number to 5 would be 5. And that's an equal sign, so we would have 5 electrons. Okay, what if we had, let's look at oxygen. Oxygen is atomic number 8. So we're going to go ahead and write that down. So atomic number, let me scratch that out. So atomic number 8. So that means we would have 8 protons and 8 electrons. Okay. Let me scratch that out. Let's go to another example. What if we didn't know the atomic number, but we knew that there were 14 protons? Well, what does that mean? Well, that also means that it's still equal. Equal is equal, right? In math class, equal is equal. So we have 14 as the atomic number. And we have 14 electrons. And if we know the atomic number does not change. So we can actually come over here and look at 14, and that is silicon. So we could actually identify the element. Please tell me another element. Please pick its atomic number and tell me how many protons and electrons it has at the end of this video. Thanks.